My name is Kiana Springer. We are in Data Visualization 625 with Prasanna Mehta. We are going to be covering network graphs, specifically the comparison of two networks and their associated security risks. A brief introduction is in an IT network, a node is any device or system on the network, like a computer, server, router, or some other application. And then an edge is the connection between two nodes, showing how data can travel from one place to another, whether it's a cable, through Wi-Fi, or some other IT link. And then the betweenness that we can see over here describes how important a node is in connecting other parts of the network. So when we have a higher betweenness score, in this case 0.25, and then down here 0.68, that indicates a stronger connection between two nodes. And likewise, a betweenness score of 0 means that it's not bridging the gap between two nodes. It's not required for information to flow through it to get to another node. And then, so like I said, if it has a high betweenness, it means a lot of network traffic depends on it. So if that system goes down, it can slow down or disrupt communication across the entire network. And this is extremely important for IT teams to understand how information flows and where the most critical points in the network are. In network 2, this one, we've got the highest betweenness score of 0.25. So right here, stealth is representing a node. So this is a pivotal connection in the network. And we can see that stealth is connected to a lot of other nodes. So if this system right here were to be infected with malware, then we would have a lot of the other nodes get wiped out. So this network number 2, since we can see the critical points, it's kind of all over like a spider web. That is what we do not want to have happen in a network. It's just indicating that if stealth or Spectre or any one of these, or if all of them, as worst case scenario, were to go down, then all of the other nodes are impacted, and it's really hard to shut down the malware in that specific instance. In network 3, we have a better pattern here because we can see that, let's say that node of Starhawk is infected with malware or some other virus. We can shut Starhawk down and it won't impact as much because it's only connected to the nodes that it needs to be connected to, as opposed, for example, in network 2, it's kind of all over the place. It's connected to all of them, where this one we can clearly identify what edges are being connected in between the nodes. So comparing these two examples, we would absolutely want to have our network set up like network 3 so that we can, 1, control the virus quicker, 2, identify where the problem is, and then be able to shut that down so that the rest of the network is not impacted. Thank you so much.